Hello everyone, I am Ümit Akkuş. In this video, we will solve one problem in chapter 6. In the figure, two boxes of masses M equals 5 kilograms and capital M equals 7 kilograms are pulled to the right by a force of magnitude F equals 52 newtons. There is friction between the boxes and the surface, and given through the coefficients mu s equals 0.47 and mu k equals 0.33. The string connecting the boxes is assumed to be massless. A. Calculate the acceleration of the boxes. First of all, we draw the free body diagrams of the boxes. As the first step, we draw the appropriate coordinate axis. For mass M, we have. For mass capital M, we have. And we represent the masses by a big dot. Notice that each mass sits at the origin of their own coordinate system. Now we draw all the forces acting on the body. First of all, we draw the gravitational force on the objects. Secondly, since the masses are in contact with the surface, we have the normal force like this. Next, we draw the tensional force on the body. And the external force F on the mass capital M is drawn like this. Therefore, the motion is to the right. As a result, we have the kinetic frictional forces like this. Finally, we draw the acceleration vector separately from the body. Since the motion is to the right, we draw the acceleration vector like this. As you see, the acceleration vector is drawn with a different color. Okay, these are the free body diagrams of the boxes. Now, we write the equations of motion with the help of the Newton's second law, F net equals ma. For mass M, since there is no motion along the y-axis, we have the normal force N equals mg. And in order to write the equation of motion along the x-axis, we choose the direction of the acceleration vector to be positive. Then the net force along the x-axis becomes T minus Fk, which is equal to ma by the Newton's second law. For mass capital M along the vertical line, we have the normal force M prime equals capital M times g. And to write the equation of motion along the horizontal line, we choose the direction of the acceleration vector to be positive. Therefore, the net force becomes F minus T minus Fk prime, which is equal to capital M times A by the help of Newton's second law. Now, we add the equations 1 and 2 side by side. Then we get F minus Fk minus Fk prime, which is equal to M plus capital M times A. If we use the expressions for Fk and Fk prime, then we use the expressions for the normal forces. Now, if we divide both sides by M plus capital M, then we obtain an expression for the acceleration as A equals F over M plus capital M minus mu k times g. Now, we put the corresponding numerical values into this equation. Then we get 1.0993 meters per second squared. Or in three significant figures, the acceleration is approximately 1.1 meters per second squared. Okay, since the result is positive, The direction that we have already chosen for the acceleration vector was correct. That is, the motion is to the right. B. Find the tension T in this string. We have from equation 1 that T equals m times A plus Fk. Since Fk is equal to mu k times m times g, we have m times A plus mu k times g. With the corresponding numerical values, we obtain the tension T in this string as approximately 21.7 newtons in 3 significant figures. Alright, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.